Hey class, in this video we're going to be taking a look at adding sensors to your robot. We will answer 3 essential questions. Why do robots need sensors? What's the difference between an analog and a digital sensor? And what do you need to add a sensor to your robot? Before we think about sensors on robots, let's think about the senses that you have as a human. What are the 5 human senses, and why do humans need senses? Did you guess all 5? So the 5 human senses are taste, smell, vision, hearing, and touch. And I have seen a movie about a 6th sense as well. Anyway, senses allow us as humans to react, communicate, and generally keep the body healthy and safe from any type of environmental danger. So engineers and scientists come up with electrical and mechanical ways to add one of these senses to a robot. It's pretty impressive, and we're going to be able to add one of these sensors to the robot that we have in the classroom. So robots need sensors to measure information, identify location or position, and also, and importantly, to avoid obstacles. As we've discussed, the autonomous period that's used during VEX robotics competitions is a great opportunity for teams to show off the use of sensors. In class, we'll be using some basic sensors to complete some basic tasks. So where are some sensors used besides robots out in the real world? Let's take a look. Do you recognize some of the sensors that you see on this slide? What's impressive to me as a teacher is to see these pictures change and develop over the past 10 years. As you know, sensors are available inside many bathrooms. Do you know why they put sensors in bathrooms? Primarily to keep people clean. Another place that sensors are very important is home security. Probably one of the first places that you would see sensors. Some of these sensors can detect movement in a room. Some of these sensors can determine whether a window has been open and shut. And some of these sensors can actually differentiate between a cat, a dog, and a human based on size. They're pretty impressive, and people spend a lot of money to have home security systems installed inside their house using these types of sensors. Maybe you have a sensor like this on the side of your house, which will turn on in case somebody moves at night. It'll turn on the spotlight. Maybe one of these hand dryers. This is actually my favorite hand dryer. You run your hand over it, the sensor can see your hand, and it turns on the air to make your hand really dry without blowing the skin completely off your hands. Maybe you have the latest iPhone that has a vision sensor on it, which can detect your face. And also in the world of automotive, we see more and more sensors being added to cars as we try to make cars more and more safe. Here's an example of a car that uses sensors to detect what is around the car so it doesn't hit any type of person or individual that might be walking in front of it. It's pretty impressive to see sensor technology continue to grow and expand as we get further and further involved into electronics and programming. It's pretty impressive. Can you think of some other examples of where sensors are used in our everyday environment? Next, we're going to be taking a look at how to use sensors for your VEX robot. To use your sensor, you need to make sure that you have the sensors, your microcontroller, and your EZC programming language. Now, there's 2 types of sensors that I want to discuss. First, we're going to take a look at digital sensors, and then we'll take a look at analog sensors, because there is a difference. Can you guess what the difference between digital and analog is? Do you know a difference between analog and digital music? Well, let's take a look in the next couple of slides. We use digital to describe these 2 sensors, the limit switch and the bumper switch, because they only give back 2 values, a 0 or a 1. Like binary code, digital sensors can only have the value of 1 or 0. Like the light switch at home in your room, the bumper switch and the limit switch can either be on or off. They are either pressed or not pressed. So when they are attached to your robot, they are giving back a value all the time. If it gives you a value of 0, it means that the button is pressed. If it gives you back a 1, it means that it's not pressed. So again, because it only gives back 2 values, these sensors are called digital sensors. Can you think of an example of when you would want to add a bumper switch or a limit switch to your robot? The next sensor that we're going to take a look at is the line follower and the ultrasonic. And there are other sensors as well, but these are examples of sensors that are analog. Analog sensors give back a wide range of values. So digital sensors give back a 1 and a 0. However, analog sensors give back a wide range of values. How big the range is dependent on the sensor. They could be anywhere from 0 to 257, from 0 to 999. It all depends on the sensor. And so analog sensors are used to determine light and sound, temperature, and distance. Let's take a look at a few examples that mimic some things you might see in nature. Here is the ultrasonic sensor, which is an example of an analog sensor because the values it gives back range from 0 to 255. When you look at the ultrasonic sensor, what does it look like? Well, if you said it looked like a set of speakers, you'd be pretty close. The ultrasonic sensor gives off a sound that our ears cannot hear. The ultrasonic sensor emits a sound, the sound then returns to the sensor, and the sensor is able to turn that distance into a value, and that value helps the robot know how far away objects are. It doesn't see it, but in some ways it kind of hears it, and that's where you get ultrasonic from the sound. Now the ultrasonic sensor that we use gives back a distance in inches, so it can help you figure out how far away things are. And what you can do with your code is you can put in a less than or equal to sign, so that when the robot sees a wall or sees an object that's less than or equal to a certain value, the robot will stop. It's a pretty impressive sensor using sound to detect where it is, and it mimics things that you might see in nature. Can you guess what I'm talking about? Well, the ultrasonic sensor is similar to sonar or radar. Here you have a bat who's sending out echolocation waves to figure out how far away that moth is. You also have a whale who's using echolocation to figure out how far away those fish are. And submarines use sonar, which is very similar to echolocation, to figure out where things are deep, deep down under the water. It's pretty impressive that humans are able to mimic things that are done in nature. Another example of an analog sensor is the line follower sensor. The line follower sensor gives back values between 0 and 999. The line sensor uses reflected infrared light. Again, light that we can't see but is emitted. It's like the remote control that you have for your TV. Infrared light is shined down onto an object, the light bounces back, and the sensor is able to determine what the value is and turn that value into a number. You can then use that value to detect the lightness and darkness of objects. It's important to have the line follower sensor a certain distance above the object. Using 3 line sensors together can allow your robot to follow a line on the floor. It's a pretty challenging project, but I've seen students do it and it's pretty impressive. So again, the robot isn't actually seeing anything, it's just using infrared light to detect what's there. Here's a real-world example where you have an assembly line where the robots move along the floor following these little black lines on the floor, which allow the robot to figure out where it has to go. And so there are sensors on the bottom of this little cart that allow the robot to see the lines that are on the floor. It's pretty impressive. So we briefly talked about the difference between analog and digital sensors. Do you remember the difference? So remember, digital sensors give back a value of 1 and 0. You have your bumper sensor and your line sensor. And analog sensors give back a variety of values, anywhere from 0 to 255, from 0 to 999. And they also work in different ways. The digital sensor actually has to touch an object, where the analog sensor either uses sound or light to detect what's in front of it. And so maybe you can think of some different uses for the different sensors that we've talked about. Now let's talk about how to use them with EasyC to have them function with your robot. What's great is that EasyC provides a test code that you can use to download onto your screen so you don't have to write it step by step as we did in the last assignment. Here's an example of the code that we can use to program the bumper switch. Remember, the bumper switch is a digital sensor, so it's going to give us back a value of 1 or 0. So we have to tell the robot what is it going to do when it has a 1 and what is it going to do when it sees a 0. We have our program inside a while loop, so whatever happens inside this loop, the robot will repeat over and over again. And we're also using a little bit of logic because we have an if and an else. So what does this mean? This means that if we connect the bumper switch to digital input number 6 on our microcontroller, if it sees a value of 1, the switch is open, and if we see a value of 0, the switch is closed. So inside our while loop, it will give back digital input information to the screen. In the if section, if the bumper is equal to 0, the motors will stop because they have a value of 0. Or else, the motors will go forward according to the code that we have on the screen. So your goal in class is going to be to modify this code so that it'll work with your robot values. You'll have to drag in the if and the else, add the motor values, and your robot will be good to go. As you use the sensors on your robot, it's important to use the sample test code that's already provided for you. What you'll do is you'll just add the while loop, you'll add the if and the else, and then add the motor values to get your motors to do what you want them to do. The other thing that you'll have to do is to edit the standalone project type to make sure that your robot works on autonomous only. As I said in one of the previous slides, we're going to be using what's called a while loop. With a while loop, it will repeat as long as the information is true. In this instance, because we've placed a 1 inside the while loop, it'll repeat everything inside that while loop forever. We've also added logic. We've added an if and an else. If this is true, the robot will do this, or else it will do that. So for example, if the bumper is equal to 0, the motors will stop, or else the robot motors will go. That's an example of logic, and that's what we're going to be adding to our program to make sure that a robot stops and goes when we need it to, using the sensor. Some things to remember: make sure that you use and read the sample test code as I showed you before, and you'll do that with each sensor. You want to make sure that you edit and use the variables and use the while loop so that the program repeats. And you want to make sure you edit the standalone project type so that the robot is an autonomous only and not looking for the joystick. So in this lesson, we had a quick overview of why robots need sensors, the difference between analog and digital sensors, and what is needed to add a sensor to your robot. When you add a sensor to your robot and your robot moves around the room autonomously, congratulations, you have successfully built a functional robot. Enjoy.